Hello friends, welcome to WebTechSchool. In today's video, we'll look at one of the problems of linked list. The problem statement says, given two linked lists, we need to find the mathematical addition of these two lists and return back the sum as another list. So in this given example, how we can return back this list. So we have two numbers 7243 and 564. If we'll do a general mathematical addition, then we will end up with this number 7807. So the problem statement asks us to create four nodes for each digit and send back the reference to head node. In mathematics, the summation actually works from the last digit. Like in case of 7243, it starts from 3, and in case of 564, it starts from 4. In the linked list, we have a reference to only the head pointer. So we need a reference to the last node for both the lists. Along with that, we also need to keep track of all the elements. So what are our options? Either we can create a stack, one stack for each of the lists. So two lists, so two stacks. So for the first stack, we'll push all the nodes starting from the head 7, 2, 4 and then 3. And then for the second list also we'll push all the nodes 5, 6 and 4. And then we'll start popping out the stacks and find the sum of the final element and push this to a result list. This approach will work. But the problem with this approach is we are using an extra space. So what will be the optimal approach for solving this? Let's say for these two given lists, if we can reverse these two lists, we will have head pointer pointing to the last node. And we can do the reverse in big O of n time. This approach we have discussed in our previous video. If you are interested, you can check that. Now, while summing, how the summation works? So we start adding the digits, like 3 4s are 7. Then whenever the sum of two's digit become more than 9, then we take a carry to the next element, right? So we need two variables. One is sum and another is carry. Both we initialized it to 0. Let's now start the addition process. So we'll create a result list, and inside the result list, we will push the sum of each digits. So for the list 1, it's 3. For the list 2, it's 4. And the carry value is 0. So we will push 7. So next we'll update the reference of the head pointer in both the lists. Now the carry value is also 0. The sum value will become 10, which is greater than 9. So we need to find what value to push into the result list and what value to take it as a carry. So we can use this formula to calculate that. So in case of 10, carry will be sum divided by 10. So carry will become 1 and sum will become 0. So we should push the sum value and we should take the carry value. Let's take another example and see if this formula works. So I'm taking 25. In this case, we should push to the result list 2. So sum will become 5, sum modulo 10. Then carry will become 2. So this formula works. So in the example, we will be pushing 0 and taking 1 as a carry. So let's push 0 and update the carry and update the references as well. Now let's add the next nodes. The addition will be carry plus list 1 value and list 2 value, which is equal to 8. So we'll update that. So we'll add the next node as 8. Then let's update the references as well. Now for the list 2, this has run out to null. So if any of the list runs out, we can think that value as 0. Then the sum value will become 7. So let's add a node 7 at the end of the result list and update the reference. On the next iteration, both the list will become null. So the result will be our final answer. But if you compare the sum value what we have got and the expected output, so this is exactly the reverse of the calculated sum. So if we'll again reverse the value, we can get the output. What will be the time complexity for this approach? For reversing the first list, it will be big O of n. For reversing the second list, it will be again big O of n. For reversing the result list, it will be again big O of n. So which will be big O of 3n, which will be equivalent to big O of n. So we can do this operation in big O of n time. We have taken an extra space to store the result list, but this can further be optimized to store the result list into the list which has larger number of elements. Let's go to Visual Studio and implement this. Now I'm in Visual Studio. I have created both the lists L1 and L2. The first list has 7, 2, 4, 6, 4 nodes, and the second list has 3 nodes, 5, 6, and 4, as discussed in the example. So now let's implement the addition of these two lists. So I'll go to this list operation.cs class. Let's create our method. So I'll create, let's say, public static, and we will return back a list node L1, node L2. The first operation, what we want to do, we want to reverse both the lists so that we have a reference to the last node. So I'll do L1 is equal to list operation dot reverse. The reverse operation we have already discussed in the previous video. So if you are interested, you can check that video. So I'll just pass in the first list. We also want to reverse the list too. So let's reverse that. Okay, so I'll just do it as L2, and this will also become L2. All right, so what we need is, let's initialize int which will equal to null and L2 equal to null. So we will keep on moving ahead. So let's just add that condition if L1 equal to null. So what we want to do, we want to go to L1 equal to L1 dot next, just to traversing through the linked list. Same thing we'll do for L2. So if L2 is not equal to null, so here we will just update L2 is create int value 1 is equal to, in case is equal to null. So it as the value will become 0, else the value will be L1 dot value. Okay, and 2 is equal to the sum. So the sum will value 1 plus value 2 plus the carry, whatever, if there is any value in carry, so we'll include that as well. And in case if the sum value is greater than 9, something we need to take as carry. So how we can calculate the carry? So we can calculate the carry as sum. This will give us back the carry. So in case, so we can just simplify this. So we can say carry is equal to, if the sum value greater than 9, carry value will become sum by 10. If the sum value is less than 9, then the carry will become 0. And in any case, what will be the value of sum will become sum. So we have got our sum and we have got our carry value. So the next operation basically in creating the result list. So let's create a new linked list or a list node. Result is new list node. Result equal to create a another reference called result head, and I'll just let's assign it to null. We will assign result head to result value when we initialize our result list. Okay, what this value will become? So if the result is not null, so we'll do result dot next. So we'll add it to the next element, the new node. So this is just adding a node at the end in the linked list, and we'll just move the result to its next reference. Result equal to result dot next. So this is all the operation that we need. So in case the last node has the sum which is greater than 9, that means we'll have some value present in the carry. So we can just add that as if carry equal to 0. Then to our result list next element, we'll add another node, should be reverse of result list's head pointer is pointing to result head. This is where we made the assignment. So we'll just pass it to the reverse list, and this should give us back our answer. Okay, so that's all the implementation that we need. So let's test this. So if I go to program.cs, and in here we will just call list operation dot r2 number, and we'll pass our both the list L1 and just say variable result, and we will display the list. I'll say list operation dot display list, and I'll pass the result to it. So we got back 7810, and we are expecting 7807. So let's see what went wrong. Okay, so we are passing over here 7246, but in the example we were passing 724 and 3. So let's change this to 3, and let's run it one more time. We got back 7807, and our expected value was 7807. That's all on adding two numbers in two non-empty linked lists. Please give your thumbs up to this video and don't forget to subscribe to us. Thank you for watching.